Hello students, welcome to my channel, The Field of Chemistry. I am Vijay Lakshmi. Today we are going to discuss about the relative basic strength of ammonia and aniline. This is very important. Which is strong? That means ammonia is strong or aniline. Aniline is nothing. It's an aromatic amine. Okay, that one we are going to discuss. And alkylation. How that alkylation, that means alkyl chloride, which is reacting with aniline. So all these points we are going to discuss with aniline with alkyl chloride, aniline with acylation. Acylation is nothing, that is acetyl compound. Okay, that is acylation. Next, mechanism of acylation. It's very important one. Acylation mechanism only we are going to discuss. Next, benzylation. See, acylation is what it is? Aliphatic. Benzylation it is aromatic. Okay. Next, carbyl amine reaction, which is very important one. Bad smell it is coming. We used to tell no in that lab, that we are going to say. Check, it is carbyl amine reaction. That means whatever it is, a primary amine or aromatic primary amine or aliphatic primary amine combined with chloroform. Just you remember this point. That reaction we are going to discuss. And with nitrous acid, a primary amine or secondary amine combined with nitrous acid, what's we are going to get that point. That means product what we are going to receive. That we are going to check. Reaction with aryl sulphonyl chloride. This is also very important question. And all these are all reactions. Sometimes they used, not sometimes, important questions they used to ask in the board exam. Board exam corner only we are going to check. Hope you just listen these points. Okay. Now, aniline in nitrogen atom is attached to the electron withdrawing group in benzene. Now, you know what is the structure of aniline? Aniline is just benzene ring in that aniline structure. Okay. Ammonia, in that one hydrogen, it is replaced by benzene group, that is called aniline, isn't it? So this is the structure of aniline. Okay, now aniline, that is a nitrogen atom attached to the electron withdrawing group of benzene. So this is attached to the electron withdrawing group of benzene. Because of this lone pair of electron involved in the resonance. Now we are going to see the resonance structure. Resonance structure means, so this is the first structure. So the lone pair of electron which is going to connected over here. So when it is going to connected over here, what happened? This part it will go unsettle over here. Suppose this lone pair, if it comes here, means naturally next to bond it will be shifting. Okay, so next resonance structure will be like this, double bond NH2. See, here the lone pair comes this side, so you will get the bond. So usually lone pairs comes here, means you will get the double bond. So from here one bond is there, no, that comes to this corner, you will get a minus. So that means here there is a bond. These are the two bonds are available, because this bond which is giving to this point, so you will get the minus. Okay, that means which is giving, it is a plus point, which is receiving, it's a minus point, minus charge. You remember this? Okay, now what happened actually? This is a plus charge. Why? Because it is donated that lone pair of electron, no, so naturally it gets positive charge, and which is receiving, it is a negative charge. Now what happened? This is a third position. This bond, this negative charge, which is going to give it to this point. Now what happened in that third position? Both the side, double bond NH2, here is a plus charge, and here, so from here it gives here, no, so it will come here. Okay, now in this point you will get it here the same way. Okay, now next one, what happened? double bond, NH2 plus charge. Now what happened this side and this side? Now the minus charge will come like rotating way, it will come here. So what happened? This will go join with here. Now this bond, it will go and accommodate in the same position. Okay, now next point, the last one, what happened? You will get the same of the first position. What is that first position? NH2. So when this bond goes that side, means lone pair, it's remaining in the same. So this is a resonance of aniline. Okay, now what is that thing I'm going to tell you? Because of this lone pair of electrons involved in the resonance with benzene ring, so it does not have electron to donate like amine, ammonia. So ammonia, it is ready to donate one electron, but in this part it cannot donate, so automatically it is connected with benzene, so it is coming to the original position. So it does not have that point of view that it cannot donate the electrons. Okay, now lone pair of electrons of nitrogen are partially withdrawn by benzene, and it becomes difficult for nitrogen to donate lone pair of electrons. This is the reason aniline is weaker base. Now that's what I would like to tell you. Aniline is weaker base than ammonia. Why? What is the reason? Because of this lone pair involved in the benzene ring. Okay, so it does not have electron to donate like ammonia. You just mention it because of lone pair of electron involved in resonance with benzene ring. So it does not have electron to donate like ammonia. You remember this 2-mark question, they may ask a 3-mark question with the structure, explain about that. Why ammonia is stronger than aniline, or aniline is weaker base than ammonia. I explain 3-mark question, they may ask you, just go through this. Hope you got it. Why? Because aniline is weaker base than ammonia, because lone pair of electrons are involved in the benzene ring, so it does not have electron to donate like ammonia. Hope you got it. The next point what we are going to discuss, para-toluene is stronger than aniline. So all these points we are going to discuss with aromatic amine only. So aniline is one of the aromatic amine. Toluene is stronger. Toluene, you know very well, toluene compound CH3 benzene bond, it is connected. So that is para-toluene is stronger than aniline. Now coming to the point. When alkyl group is present on the nitrogen atom of aniline, is increase the strength. Remember that primary amines, secondary amines, tertiary amines in the last video we have discussed. So secondary amines are stronger than primary amine, and primary amine is stronger than ammonia. All those things we have seen. But here aromatic amines, that means aniline is weaker than ammonia. Aniline is actually primary amine, no, but that is also weaker than ammonia. I think this point I have explained why aniline is weaker than ammonia. I have explained. Okay, but here toluidine is stronger than ammonia. Why? Because the nitrogen atom, electronegative group, nitrogen atom is present in that benzene ring. That is the reason it is increasing the strength. That is what they are mentioning. An alkyl group which is attached over the toluene formula, you know very well. This is benzene ring. In that CH3. Okay, so because of that alkyl group, why? Because of alkyl group, that is easy electron releasing group. So naturally it is having a strength to push the electron. So naturally nitrogen atom is pushing the electron towards themselves. So it is interconnected with another molecule that I have explained in the last video that you have seen. Okay, now in this, but when you are going to that higher molecules like benzene ring, electron withdrawing group, that is electron releasing group. Alkyl group is electron releasing group. Remember that alkyl groups are electron releasing group, but benzene ring, it is electron withdrawing group like benzene ring, which is present in the nitrogen atom. That will be decreasing the basic strength. Note the point. So why toluidine is stronger than aniline? Because here alkyl group is present. Toluidine in that alkyl group is present. But in benzene aniline, this is aniline formula. No, this is aniline formula. Okay, this is aniline formula. In that electron withdrawing group which is connected to the amine. So naturally the the basic strength which is decreasing, but toluidine which is increasing because of the alkyl group which is attached to the benzene ring. Why alkyl group? It is basic strength is higher because it is electron releasing group which is pushing the nitrogen atom, and then density of nitrogen which is increasing, and it is ready to donate the electron. Last video I have explained very clearly. Hope you got it. Okay, next one. Let us discuss some of the compounds, how that basic strength it is of aromatic aniline compound. Okay, now here dimethyl phenylamine. This is dimethyl phenylamine. What is the Ka value? Ka means acidic strength. Okay, now what is the Ka value? 11.9 into 10 to the power of minus 10. When you are going for methyl phenylamine, this is methyl phenylamine. So here 7.9, comparatively this is lesser. Why? Because here methyl group is more. Here only one methyl group it is there. Why methyl group? Because acetylation, acetyl group is having electron releasing group. Remember that. Next, aniline. Aniline is actually very less comparatively methyl phenylamine or dimethyl phenylamine. Okay, now aniline, actually there is no alkyl group is attached, only amine group attached over to the benzene ring. Okay, next diphenylamine. This also comparatively very less, 6 into 10 to the power of minus 10. Okay, remember that. Next one, triphenylamine, which is very low. They didn't even give the point. So that means you remember that MCQ, they may ask what is the Ka value of any one of this, and you just remember this point, tips like I'm giving. Wherever it is a methyl group higher, that means acetyl group which is higher, that will be Ka value, that is acidic strength, basic strength will be more. Okay, remember that. Sorry, Kb value I mentioned. I'm sorry, Ka value I mentioned. This is Kb. We are mentioning about the strength of basic nature only we are discussing, no? So here basic value, Kb value only, basic strength only we are discussing. So which is having more basic character, that means here which is having more, so naturally dimethyl phenylamine. So that means wherever methyl group, acetyl group, wherever higher point, that will be the highest Kb value. That means basic strength value will be higher. Hope you got it. Okay, next one more point which is very, very important. Acylation. Acylation means what it is? Acetyl chloride. Acetyl chloride. Okay, so acetyl chloride CH3COCl. Acetyl chloride combined with primary amine or secondary amine or tertiary amine, whatever it is, amine, that reacted in the presence of pyridine. Pyridine we are going to take. That is actually a catalyst only. You know what do you mean by catalyst? It just makes the reaction faster. So pyridine we are taking as a catalyst, and then we are receiving the product of N-methyl acetamine. Okay, now why we are taking pyridine as a catalyst? They may ask the question. Pyridine is a stronger base. Okay, pyridine actually what it is? A stronger base than amine. Hence, it removes the acid formed during the reaction and shift the equilibrium, right? So, why do we take that pyridine? Because it is a stronger base comparatively to the amine. Okay, comparatively to the amine means what it is? Here we are mentioning the primary amine only. Primary amine only we are taking it as a reactant. Hope you got it. CH3 NH, here NH2. So methyl amine, no, CH3 NH2. Here I have written like this for convenience. Okay, Cl I will write it here. C double bond O CH3. Just I have written like this way. CH3COCl have written. Why? You know, for this convenience only, you no need to by heart that equation. You just see that how do we get the product. Now you just write as it is. CH3 NH C double bond O CH3 amide NHCO CH3, it is called amide, no? So this is what it is, primary amine, that is a methyl amine. Methyl amine. Okay, now this is acetyl chloride. Acetyl chloride. Can you see? Yeah. Okay, now this is what it is. Here in the presence of pyridine. Pyridine as a catalyst. Catalyst. Why do we take pyridine as a catalyst? Because actually comparatively more than what it is primary amine, pyridine is more stronger base. That is why to get the proper equilibrium, for that sake we have taken. Hope you got it. Okay, now CH3 NHCOCH3, it is a amide. Okay, acetamide or acetamine. See, this is amide compound. NHCO alkyl or aryl group comes means it is a amide. Okay, in this part it is a amide. Okay, acetamide, that is CH3 group is there, no? So acetyl, so that means only one methyl means acetyl. Okay, that means acetamide we have written. Here only one methyl group it is there, so N-methyl acetamide, this is the name of it. Okay, now next one, see, next one more reaction we are going to take, that we see C6H5NH2. What is it? C6H5NH2? Naturally, aniline. Okay, and this is what it is? Acetyl chloride. Acetyl chloride. Okay, now pyridine we have taken. Why? The same thing only. Instead of what it is, aliphatic amine, we are going to take aromatic amine, which is called aniline. And we have written the same thing, removing that HCl. Now what happened? C6H5NH C double bond O CH3. Now what is the name? Acetamide. N-phenyl acetamide. Just you write it as it is. That's all. So this is acetamide. Acetamide, NHCOCH3, it is called acetamide. Okay, amide group. Then here N-phenyl. Okay, phenyl group only it is attached. So, N-phenyl acetamide. So, this is the name of this. Okay. Now, the same way, whatever you have written, that is methylamine you have written here. Aromatic amine, that is aniline you have written. Benzenamine you have written. Hope you got it. Next one, the same way, C6H5NH. Instead of acetyl chloride, here acetic anhydride. I think you have learnt in aldehydes and ketones acetic anhydride. How do we get that acetic anhydride? You just write this. Here I have written this formula, C double bond O. Here C double bond O. Here CH3. Here CH3. That's what I just have written this side. CH3 C double bond O, CH3 C double bond O, both combined together it is O. So it is acetic anhydride. Acetic anhydride. Okay, now this is what it is, aniline. Primary amine, methyl amine also you can take, phenyl amine, what it is, aromatic amine also you can take. Okay, now what happened here? Same pyridine we have take it as a pyridine as a catalyst. See, instead of acetyl chloride we have taken acetic anhydride. Now what happened? This hydrogen combined with this one part of complete combine. Now CH3COOH, that is what it is, acetic acid. Now remaining acid is, you can write it C6H5NH C double bond O CH3. The same molecular formula you got it now here. What is this? N-phenyl acetamide, the same formula which is remaining. Only thing, subproduct we are receiving, what it is? CH3COOH. What it is called? Acetic acid. Hope you understood this. See, if you have written like this equation, it will be easy to understand the formula and easy to get the product. You will not get any mistakes. If you write it in a correctly, if you are writing a formula, you will get a product very clearly and you will get the full mark. Hope you got it. See here. The next equation, not only primary amines, whether it is aliphatic or aromatic, even a secondary amines also can react. See here, CH3NH, So what it is this? N-dimethyl amine. Okay, so that means 2 acetyl group is available, 2 methyl group is available. It is replaced by 2 hydrogen. Okay, now the same way, HCl it is removed, then remaining what it is, the same thing, pyridine as a catalyst. So CH3N, then one hydrogen also is gone, CH3, here double bond you will get it. See, this is the product, CH3N, CH3, that HCl has gone, C double bond O, here double bond O, CH3. So what is the name? N, this is acetamide, NC double bond O, always nitrogen combined with CH3 acetamide. So here 2 methyl group is there. How can you write it? N-dimethyl acetamide. Can you see that? N-dimethyl acetamide. Hope you got it. Okay. Next one, mechanism of acylation. Now what we have seen, that we are going to check in that what it is, mechanism. See, amine acts as a nucleophile and it attacks the carbonyl carbon, that is carbonyl carbon C double bond O, okay, of acetyl chloride, giving intermediate to lose H plus and Cl minus ion, okay, giving a final product, that is a amide. Okay, now when I am writing, you will come to know very clearly. Okay, see here, CH3NH2, lone pair of electrons. Okay, and acetyl chloride, acylation, no, acetyl chloride, CH3COCl. Okay, now you know very well, okay, oxygen is having more electronegative, so it pulls the electron towards themselves. When it pulls the electron towards oxygen, what happened? This is a negative charge and a carbon is having a positive charge. So this lone pair which is going to attract it towards the carbon, that means a nucleophilic substitution reaction takes place. So here what happened? Here you will get that ion, what it is, H plus and Cl minus ion. Here you will get it here, okay. This is the compound we are receiving. Actually, when it gives that lone pair, automatically you will get a positive charge. See, same thing, just CH3NH2 positive charge. And then here what happened? Single bond, because that here I have written ulta, Cl has gone there. Okay, oxygen double bond, no, single bond, and it is a negative charge because that bond is attracted towards the oxygen, no, because of electronegativity. So it is a negative charge. Okay, now next one, in this place Cl minus ion, it is going to sit over here. So that is what Cl minus, and then same as it is. Okay, now what happened here? Next part, what it is going to get it here, this point, this bond which is going to connect it to the nitrogen, this bond. Okay, now next one, what happened? This negative charge which is connected to the another one more bond. Okay, that means this bond which is attracted towards the positive charge of H plus ion. See here, this bond which is connected to this positive ion of N plus, then naturally when it goes giving the pressure over here, this negative charge comes this side, and then this bond which is breaks that bond, then it will come here. So what is the answer? CH3 NH C double bond O CH3 plus HCl. Okay, so HCl, it comes out. Okay, this is the mechanism. Okay, hope you got it. This is methylamine, methylamine. This is acetyl chloride. Okay, this is the mechanism takes place. Then you will get the product N-methyl acetamide. Okay, mechanism, you got it. This one, it's very easy. Because of carbonyl carbon nucleophilic substitution reaction takes place, the lone pair of electron it is attracted towards the carbon, and this Cl, it is which is connected over here. This is this Cl carbon. Okay, now in this way it is taking place. Then you will get a acetamide. That reaction what we have seen, that is the mechanism. See, another one more reaction, benzoylation. Already I have given idea about what is acetylation. Benzoylation, the same thing. This is actually what it is, aromatic amine. Okay, aromatic amine is nothing, aniline. Okay, now acetyl chloride. This is acetyl chloride. This chapter is very easy one, because here acetaldehyde, what it is, aldehyde and ketones you have seen, phenols, alcohols you have seen, haloalkanes and haloarenes you have seen. All those things, if you go through thoroughly, this will be very easy. You will finish it off. Okay, now what happened? What is the thing product you will get? C6H5N. Here NH actually, H, because primary amine, no, aniline, it is C6H5NH2. So here what it is, C double bond O CH3, N phenyl acetamide. Okay, so this is benzoylation. Benzoylation is nothing, acetylation only. Acetylation, acetyl chloride, it's reacting with aniline. It is called benzoylation. Hope you got it. The next reaction, which is very important one, carbyl amine reaction. Carbyl amine reaction is nothing, carbyl amine, which is easy to remember, chloroform. Chloroform mixed with primary amine. So primary amine is heated with the mixture of chloroform and alcoholic KOH. These are the 2 points you just remember. Chloroform mixed with alcoholic KOH, and it's giving what it is, isocyanide, which is very intolerable smell. It's formed. You can't even bear that smell. It's so bad smell, you will get it. Okay, now you remember those points, because in practical you just learn only. You can't do it. If you are doing, you can't even bear that that much bad smell, you will get it. Carbyl amine reaction. Okay, so here I will write the equation. Primary amine, any amine, primary amine, whether it is aniline or methyl amines. Methyl amine only we can take CH3N. Here I have written in this way, so it will be easy for you to remember. See here, CH3NH2, it is a methyl amine. Methyl amine. Okay, methyl amine connected with chloroform. This is called chloroform. This is alcoholic KOH, potassium hydroxide. Okay, this is a mixture. Alcoholic KOH with chloroform, it's a mixture. Treated with what it is, primary amine, you are getting isocyanide. This is called isocyanide, CH3NC. CN means cyanide, NC means isocyanide. Remember this, and see, this is the way I have, this is easy way. CH3NH2, this is methylamine plus chloroform, and connected with KOH, you are getting a isocyanide. I have written very clearly here. Just break that thing, and I have written here CH3NH2 plus chloroform. This is CHCl3. CHCl3. Okay. And you are getting what it is. Now you just write it in such a way. HCl, and here also HCl. You just remove all these three. This is 3 HCl, and water molecules also will be removing. Then you are getting a main thing, which is called isocyanide. Okay, carbyl amine reaction, which is very important, and it is an intolerable smell. They may ask the question, which is giving intolerable smell? Write that equation or explain that reaction. That is nothing, carbyl amine reaction. Carbyl. So carbyl amine means chloroform mixed with KOH. That is a mixture. You just note down here 3 water molecules. Now that is comes from KOH. We remember this. See here, methyl amine reacted with chloroform mixed with KOH. You are getting methyl isocyanide. Okay, which is very intolerable smell you are getting. Even for aniline also, C6H5NH2, this is also primary amine, which is aromatic primary amine, which is connected with same bond have written here. So here I can write C6H5NH2. Can you see this? C6H5NH2 plus here what it is, CHCl3, which is called chloroform, plus KOH. It gives what it is, the same thing here. It's Cl. You just remove this. Okay, now here what it is, C6H5NC. C6H5NC. So this is what it is. Here CH3NC means methyl isocyanide. Here C6H5NC means phenyl isocyanide. Phenyl isocyanide. Okay, C6H5NC phenyl isocyanide plus 3 HCl, 3 1 2 3 3 HCl plus 3 H2O. 3 H2O we are getting from KOH. Okay, you remember this? This is carbyl amine reaction, which is very, very important question. MCQ they may ask, 2 mark question they may ask, or 3 or 4 equation. In that C6H5NC we are getting what is the compound? Compound A, compound B, like that they may ask. Okay, hope you remember these points. In this point, one thing I forgot to tell you, this reaction is answered only for the primary amine. Remember that it will not react with secondary amine or tertiary amine. It will react only with the primary amine. Hope you got it. Next one. The next one, what we are going to learn, reaction with nitrous acid. Nitrous acid we have to prepare whenever we require. So how to prepare nitrous acid, I will tell you. So here what it is, NaNO2, sodium nitrate plus HCl. What happened here? HNO2. So this is called what it is, nitrous acid. Okay, and plus NaCl. So this is actually unstable. Very soon it will lose their character. So that is what, whenever we require, that time we can prepare sodium nitrate. This is called sodium nitrate. Sodium nitrate mixed with HCl, you are getting nitrous acid. This nitrous acid only going to react with primary amine. So aliphatic primary amine. Aliphatic primary amine. What is aliphatic primary amine? CH3NH2. Okay. Plus here I have written in such a way HONO. I have written in that. So it will be easy to reduce that. Okay. NOH. I have written in this way, so it will be easy. Now, what happened? This H2 and this O combined together, water molecules which is releasing. Now, what is it remaining? CH3N double bond N, and here I forgot to write it. Here actually HCl have written. Okay, this HCl actually HONO mixed with acid. Now here also one water molecules which is losing, 2 water molecules. So here what happened? CH3N double bond N. So this is actually what it is, methyl diazonium, N double bond N, methyl diazonium, which is unstable. Okay, now again it is reacting unstable. Now again it gives the product CH3OH, primary alcohol you are receiving, plus N2 plus H2O you will receive. Okay, now this is what it is, methyl alcohol, which is called primary alcohol. Methyl alcohol. Okay, now this is a diazonium salt. Okay, now here primary aliphatic primary amine which is reacted with nitrous acid HNO2. So I have written here HNO2 I have written. So easily we can remove that. In that H plus ion, H plus, that means it is reacted with HCl also to get easy the formation. For that sake only we are adding HCl. Okay, now primary amines means not only aliphatic, even for aromatic also it is going to react. Aromatic primary amine, what it is? Aniline. Aromatic primary amine. So what is this? C6H5NH2. plus the same way I'll write it ONOH plus HCl. Here water molecules releases H2O. See here H. Okay, water molecules minus H2O. Okay, C6H5N double bond N. Okay. And Cl it is there. Here also Cl. Okay, diazonium salt, actually methyl diazonium chloride, it is a salt. Okay, now again it reduces. This is unstable. Again it reduces and you are getting what it is, phenol, you will get it. Okay, now here actually how much you are giving temperature? 273 to 298 Kelvin. You remember this point? Not here. See here, aniline reacts with nitrous acid along with HCl at 273 to 298 Kelvin. So, benzene diazonium salt, benzene diazonium chloride, this is called benzene diazonium. Azo compound, N double bond N, it is called azo compound, diazonium salt, because Cl it is there. Here methyl diazonium chloride. Okay, and this is benzene diazonium chloride, methyl diazonium chloride. Hope you got it, this one. Okay, next one. Here what happened? This is also called diazotization. Okay, diazotization is nothing. C6H5 N double bond N Cl. See here, further it will not react. Why? It will be very strong. That means it will be stable. But when you are, whereas if you are going for methyl, primary methyl amine, what it is, CH3NH2 methyl amine, if you go, means this diazonium salt, methyl diazonium salt, which is very, very unstable, again further it will decompose into primary methyl alcohol, you will get it. Okay, but when you are going for aromatic amine, C6H5, this is called aniline. Aniline combined with nitrous acid, okay, at along with HCl at 273 to 298 Kelvin, you are getting a diazonium salt which is called benzene diazonium salt, C6H5N double bond N Cl. I hope you got it. Water molecules, it is releasing NO. I have written purposely so you will remember this point. You just go through thoroughly. C6H5NH2 plus ONOH. I have written very clearly here. Okay. Remember this point. Okay, C6H5 N double bond N Cl, benzene diazonium salt. Okay, what is this reaction name is diazotization. We explain the diazotization. 2 mark question or 3 mark question they may ask that. Okay, hope you got this. Okay, the next reaction with aryl sulphonyl chloride. Aryl sulphonyl chloride, it is benzene aryl means benzene compound which is connected to the sulphonyl SO2Cl. So C6H5SO2. This is actually Hensberg's reagent also we can tell. This is one more point. Benzene sulphonyl chloride also we can say. Heisenberg's reagent also we can say. Now with primary alcohol. Primary amine. Primary amine naturally what it is? CH3NH2. Now I will write it here in this way. C6H5 SO2, S double bond O, this side also O, Cl. Okay, in this HN, this also H, here CH3. See, CH3NH2, methylamine. Okay, here what you will get Cl HCl you will get. So which is remaining if you are heating with this. So primary amine reacts with benzene sulphonyl chloride to form what it is? N-alkyl sulfonamide. So NH S double bond O. CO comes means amide. Here sulfonamide. Okay. Here acetamide. This is sulfonamide. Okay. What it is? This compound which is known as C6H5SO2Cl. What it is? Heisenberg's reagent, also known as what it is? Benzene. N-benzene sulphonyl chloride. Chloride. Okay. This is methylamine. Amine. Okay, now here what is the answer you will receive? Here what HCl it has removed, then benzene ring, yes, double bond O, here double bond O, here NHCH3. So what is the name? Here actually N-methyl. Here N-methyl benzene sulfonamide. Okay. Now this is on speciality, it is there. C6H5SO double bond O, this side also double bond O, NHCH3. This H, it is actually what it is? Acidic hydrogen. This is called what it is? Acidic hydrogen. One special point I would like to tell. So alkyl what it is? Alkyl sulfonamide contains acidic hydrogen on nitrogen atom, which is attached to the nitrogen atom, an electron withdrawing group of sulphonyl chloride, which is connected with sulphonyl group. Hence, it is soluble in sodium hydroxide. Okay. When it is combined with sodium hydroxide, what happens? It will become a homogeneous mixture. That means combined together, it will become a homogeneous mixture. Okay. On acidification is insoluble sulfonamide, which is formed, that is called formed as a precipitate. Okay. This acidic hydrogen only present in the primary amine. That means methylamine. When you are going for secondary amine and tertiary amine, you will not get that acidic hydrogen. See, hydrogen is there means hydrogen bond is there means naturally it will be soluble in water. Already I have explained about that hydrogen bond. Okay, so wherever you are getting the compound of hydrogen attached to that group, it will be easily, it will, what it is, soluble in water. Okay, remember that point. Secondary amine and tertiary amine, it will dissolve, but not that much. Partially it will dissolve. Why? Because hydrogen, here one hydrogen has removed, so one more hydrogen which is remaining. But in secondary amine, here also one hydrogen it is removed. So that means acidic hydrogen is nil. Tertiary amine, there is no hydrogen at all. Okay, you remember that point. In this acidic hydrogen is there, it will be easily soluble in water. Okay, it will become a homogeneous mixture. See here. Now secondary, this is secondary amine, CH3, NHCH3, this is secondary amine, dimethyl amine. Okay, secondary amine, which is called dimethyl amine. Here methyl amine, primary amine. Okay, here primary amine. Okay, now the same compound, what it is? Benzene sulfonamide, N-benzene sulphonyl chloride. Okay, this is reacting with secondary amine. What is the product we are going to receive? Here, see, now hydrogen, one hydrogen also, it is removed, minus HCl. Now here what happened, there is no acidic hydrogen. Here at least one acidic hydrogen is there. It will be ready to soluble with NaOH or neither water molecule. But here there is no hydrogen. It will be soluble, but you will get what it is, precipitate which is insoluble in sodium hydroxide. Okay. Why? Because there is no hydrogen bond. Okay. Partially soluble, but it will sometimes it will not be soluble, partially soluble sometimes. Okay, tertiary amine do not react with this compound. What it is, sulphonyl, benzene sulphonyl chloride, it will not react. Tertiary amine do not react. Tertiary amine do not react. React with what? Benzene sulphonyl chloride. This will react, you will get a compound, but it will not react with NaOH and form a homogeneous mixture. Why? Because it will not dissolve, only because there is no hydrogen bond. Hydrogen bond. Yeah, correct. Okay, here there is a hydrogen bond. Hope you got it. All these reaction points I have given very clearly. You just go through thoroughly. If there is any doubts, you please write it in the comment box. Subscribe my channel. Put the like button. Thanks for watching.